It is time to shift gears and return to the discussion about problem solving. Let's talk about facts in life. No, not those facts. The facts I'm talking about are those we use to decide which rules to apply to a prickly problem in everyday life. On to the third element of problem solving, facts. If we continue the metaphor of a hollowing skeleton presented in the last video, in which rules and principles are the framework, facts are the muscles. They get things moving in the mind of a problem solver. As with most things, facts can have one or more functions. First, they can be used to eliminate and or support hypothetical explanations, as counterfactuals or as evidence, even though it was not historically used as a counterfactual. An example is Foucault's pendulum. It was originally installed in 1851 at the meridian of the Paris Observatory. It has been duplicated in many science museums across the globe, and even at the South Pole in the staircase of the Amundsen Scott South Pole Research Station, while it was under construction. The fact the pendulum moved relative to the ground over a day demonstrated that the Earth was spinning on its axis, and not that the stars were speeding around the Earth. Even though Foucault's pendulum was not needed to resolve a pressing problem, it does show how a cleverly designed demonstration can point to a deeper explanation and capture the imagination of children and adults alike. Second, beyond a counterfactual or evidence, facts can be used to expose a missing explanation from what appears to be a full set of potential explanations. For example, the microwave radiation that Arno Penzias and Robert Wilson inadvertently detected in 1964 at Bell Labs eluded an obvious explanation. Originally, they were just trying to detect faint radio waves bouncing off of echo balloons, launched to study the feasibility of a global satellite communication system. The experiment required fine-tuning of the Holmdel-Horn antenna for the ECHO project and elimination of extraneous interference from such sources as radio broadcasting and the detector's own heat signature. Despite all their best efforts, they were unable to eliminate a persistent hiss at a wavelength of 7.35 centimeters. They eventually concluded that the unknown source was outside our galaxy. Through collaboration, the fact was finally hooked up with the Big Bang and its hypothesized cosmic microwave background radiation, or CMBR for short. Penzias and Wilson received a Nobel Prize in 1978 for their effort, since they were the discoverers, despite not making the connection to CMBR right away. The hiss was a solution begging for the right problem. As an added bonus, it was also used to support the Big Bang theory over the steady-state theory. Third, to fill in the missing space, facts can serve as a starting point for new rules or models. That process will be explored in more detail when we look at Principle 3, an effect has causes, in the videos on causation. One part of it, the creation of new rules, was covered briefly in several slides in the last video, where I showed how simple logic and assumptions lead to at least the formal part of a causal relationship. However, to provide a quick example of new rules, in 1610 Galileo peered through his new improved telescope, and behold, he saw the moons of Jupiter, which he did not realize were moons at first sight. It required more than one sighting to determine that the points of light were actually satellites orbiting Jupiter and not background stars. This sighting was the first extraterrestrial example of a completely self-contained gravitational system visible as a whole. Galileo's discovery, along with other facts, eventually displaced the geocentric model of the solar system. It also led, in concert with other facts and theories, to Newton's law of gravity, which almost every American schoolchild learns of or hears about before entering high school. As an aside, a less taught part of Newton's genius was showing that Kepler's three laws of planetary motion could be derived from his law of gravity and his three laws of motion. Gather enough brand spanking new rules and models together, and something even more miraculous happens. A new view of reality emerges, as happened when Newton proposed his three laws of motion. In particular, Newton's three laws of motion can be cast as extensions of the three basic principles of object reality, hopefully being made explicit in these videos. Let's tablize it, as I am wont to do. Again, the three principles of object reality are: first, an object exists. Second, an event happens, and third, an effect has causes. If we list out Newton's three laws of motion, we have Newton's first law is the law of inertia, abbreviated here as inertial mass. Fully stated, an object at rest will remain at rest, and a moving object will continue to move with a constant velocity unless acted upon by a force. Newton's second law is the law of mass and acceleration, abbreviated to force, mass, and acceleration. That law says that the force applied to an object is proportional to the object's mass and acceleration. Newton's third law is the law of action and reaction, shortened to equal and opposite force. This law declares that when two bodies interact, they apply forces to each other that are equal but opposite. Then, if we combine the object real principles with Newton's laws, the principles of object reality become 1. All objects exist with inertial mass. 2. All events happen according to force laws. And 3. All effects have causes which are equal and opposite. As far as I can tell, which really isn't all that far, these modified principles of object reality are not an explicit position that Newton took. And I would be surprised if Newton would have agreed that his laws are extensions to the object real principles as presented here. From what I can gather, Newton took an agnostic approach to issues which he deemed outside the realm of science, or which were beyond our ability to answer, even if he wasn't above religious speculation. A case in point is his explanation of gravity, or more specifically, his lack of, which he demurred on because he truly did not know, nor did he think he needed to. Still, I would argue that the correspondence between principle and law is more than a happy coincidence. It is one of the reasons Newton's laws were and are so intuitively powerful. It was also a nice and unexpected little realization, which suggests that the exploration of the three principles of object reality is not a waste of my free time. These relationships, and how it has affected our view of reality and consequently the direction of physics, will be explored in one of the later videos on causality. It is another example of applied philosophy and physics, which I have chosen to call sophism. Newton's new sophistic universe was the direct synthesis of so many facts, rules, and models. Of course, the vast majority of problems and issues is not born from world-shattering facts. Back to the personal case at hand, the mystery of the broken cheese slicer, started in the last video. Not as intellectually challenging as gravity or quantum entanglement, but still an illustrative example of problem solving and its elements. To review, when I was in elementary school, I had put away the dishes from the dishwasher. In the process, I had carelessly slung the cheese slicer into the silverware drawer and, unbeknownst to me, broke the slicer. After a parental inquiry, the facts appeared straightforward. They were used primarily to eliminate possible explanations and to strengthen the leading hypothesis. Facts have been gathered through investigation of the crime scene and through interviews. Here were the pertinent facts. The cheese slicer was intact when it was put in the dishwasher. The cheese slicer was isolated from large or heavy dishes. I was the one to put away the dishes, including the cheese slicer. The cheese slicer was broken. My sister was at her flute lessons during the time of the crime. My dad got home after the crime was discovered, and I was a kid. As can be seen from the list, true facts don't lie, unlike people. Let's quickly walk through what facts are often juxtaposed to in order to characterize them. Quick prelim. The intent here is not rigorous delineation, but rather broad brushstrokes. So diving right in. Facts are not falsehoods. Example, claiming that the earth, just like Asgard, is flat does not make it so. Facts do not contain opinion. Example, if I maintain that dogs make better pets than cats, that position would be an opinion, even if I have facts to support my position. We have both at our home, by the way, to head off any protestations. Facts avoid moral judgments or values. Example, arguing that it is wrong to favorably review an Amazon product after receiving payment to review it is a moral judgment. Facts are not guesses, conjectures, hypotheses, or predictions, which is an easy line to cross in simple cases. Example, saying that the sun will rise tomorrow is not a fact, even though it will most certainly be a fact when in fact the sun does rise tomorrow. factually speaking. Very importantly, facts are not theory, even though a fact, which may require due diligence to establish its truth, can sound a lot like one. For example, after gathering all the supporting facts in their case, my parents thought they had established that I had lied about the broken cheese slicer. One could say that upon coming to an evidence-based judgment, it was their theory that I had lied. At that point, it was not a fact that I had lied. More on the distinction in a second. Continuing on, facts are not scientific laws. Example, Newton's law of universal gravitation can be used to make true predictions about the position of heavenly bodies, which eventually become facts, but the law itself is not a fact. Facts are not a priori truths. Example, saying that parallel lines in Euclidean space will not intersect is undoubtedly true, but it is not a fact. And finally, facts are not absolutes. Example, Descartes' cogito ergo sum, I think therefore I am, on its surface is unconditional and accordingly is not a fact. Before exploring more about facts, I wanted to delve a little more into the distinction between fact and theory, which is not always cut and dry. In other words, today's theory in one sense can become tomorrow's fact. However, in another sense, a theory requires causation, the hallmark of an abductive explanation. Now, if they had said I had lied because I was afraid of punishment, which is what they were probably thinking, that would be a proper theory, a proper abductive explanation. Again, I'm not a word police. One word can have multiple meanings or shades of meanings. I have no problem with defining a hypothesis as the input into the scientific process and a theory as the output. Under such a scheme, a hypothesis could be any simple or compound statement. It can get its start from logic, observation, or imagination, using any of the three inference engines, deduction, induction, or abduction. However, the hypothesis doesn't become a theory until it has been repeatedly verified experimentally by a number of separate experiments. What counts as verification can be left as an open question at this point, since we have plenty of examples of good experiments. Grab some Lego pieces, assemble, attach a pressurized air source, and release. Presto, Newton's third law in action, equal opposite action reaction. Interestingly enough, what is often overlooked is how today's theory can become tomorrow's fact in the scientific method scheme of things. Taking the case of the broken cheese slicer, if I had started to lie consistently, the theory under the scientific method would be that I was a pathological liar, someone who could not stop themselves from lying. Once that had been established, it could be used as a fact going forward to support the next theory about my behavior. For example, if I had started to exhibit narcissistic behavior, such as believing I was the greatest thinker who ever lived, my compulsive lying could be used as a fact to establish a theory of narcissism. Science takes this building block approach to knowledge, in which today's theory is tomorrow's fact. I guess it all depends on how the scientific tidbit is used. Even though some would like to maintain that conventional theories like natural selection and quantum fields are distinct in kind from such facts as the extinction of the dinosaurs and the atomic absorption of a photon. More on that later in the videos on causation. There's no denying that the scientific method is powerful in establishing and extending knowledge, and it is kind of nice to have a simple universal methodology that unites so much process and terminology. However, if you ask me, it's too simplistic, too idyllic. It smooths over some of the rough spots in the pursuit of knowledge. For example, the scientific method offers little insight into asking the original question, proposing the potential answer, and setting up a corresponding experiment to make progress. A prime example was Einstein asking at 16 years old what it would be like to travel at the speed of light. In other words, how to use or adjust our sophistic assumptions and experiential rules to understand nature's inner workings. That part is more art than science. I would maintain that it is this sophistic art which requires an understanding and manipulation of object reality, centered inside a constrained infinite unreal, and conjoined with the scientific method, that makes science scientific. It is a union of the informal with the formal, a merging of imagination and logic, and a blending of items from abstract object reality and the infinite unreal. The fleshing out of this idea will have to wait until the videos on causality. However, the main point here is that the tension and resolution between the two drives a lot of exploration and helps us problem solve. In particular, flights of imagination need the check of hard facts, and theoretical dogmata need the rebellious what if. Unfortunately, an issue arises when one side of the equation gains the upper hand and sweeps the other under the rug. It leads to loose talk and to misconceptions hiding as incontestable fact or principle. For example, it can lead to thinking that the laws of nature are causal like human laws, that a theory derived from the scientific method is a sufficient abductive explanation, or that mathematical truth is a valid replacement for fact, which in some eyes have become low chicken in the pecking order. It is a self-examined life that is worth living. So a fact can be juxtaposed to many things, such as a falsehood, an opinion, a value, a guess, a theory, a law, an a priori truth, or an absolute. However, that only gets us one step beyond the starting point. Definition by negation by what a thing is not is inherently circular. For example, saying a fact is not an opinion begs the question, well then what is an opinion? And saying we'll know it when we see it doesn't cut the mustard. Now that we have established in abbreviated non-academic fashion what facts are not, we should quickly look at what facts are, starting with the most subjective to the most objective properties. Again, it is more survey than definitive exposition about facts and their corresponding philosophical issues. Let's begin. Facts are perceivable either directly or indirectly. Example, it is a fact that the dinosaurs lived on Earth over 66 million years ago, before they went extinct, except for a few holdouts. Facts are measurable. Example, this morning's earthquake off the Pacific coast had a measurement of 9.2 on the Richter scale. Facts propose something as true, even if they are wrong or disputed. Example, if Sam I Am was real, it would be a fact that Sam I Am's friend does not like green eggs and ham. Facts can be otherwise. Example, the friend of Sam I Am eventually liked green eggs and ham. Facts answer the question, what is or was the case? Example, the cat passed through the left window. Facts are contingent on experience. Example, I saw the tree fall. If we are to relate facts to these videos in object reality, facts are about objects, events, their corresponding properties, or their causal relationships. Example, atoms exist and can be used to make home movies. Facts are verifiable. Example, if I count 2 crows sitting on the fence, you should be able to count the same, unless of course one of the crows leaves, or another crow joins the murder. Finally, and most importantly, they are objective, independent of who or what observes them. Example, it is a fact that there is a full moon tonight, whether I look at it or not. Of course, objectivity all comes down to the elusive standard, the reasonable, good faith, rational person. If one chooses to be unreasonable or irrational, to flat out lie or to wholeheartedly believe in fantasy over reality, no amount of argument or evidence can dissuade such a person. For example, one can deny that the moon is overhead by simply denying one sees it, even if looking straight at it. What I say goes, unless we develop a technology to read the minds of others. Rue that day. Facts are a lot of things: perceivable, measurable, proposable, negatable, actual, experiential, object real, verifiable, and objective. However, to be honest, the spectrum of fact versus fiction or fact versus belief is not so black and white. Some would like us to believe that facts, once established, cannot be questioned. In other words, a fact is a fact, and that is that. Yet, if we are honest with ourselves, there is always some wiggle room. It is just that as more good faith consensus is reached, and as more evidence is compiled, the wiggle room gets tighter and tighter. At some point, there's almost no room to wiggle, and saying otherwise, no matter how many say it, does not make it so. Still, cold hard fact will always have a human handprint on them. There is no getting around that. Even with that limitation, we do the best we can with what we got. Kids will be kids, and parents will be parents. Going back to my personal example, on its surface, the broken cheese slicer case appeared open and shut. It appeared that I had lied in denying responsibility for breaking the cheese slicer. Not so fast. Some of the facts were missing. From my point of view, I had not intended to break the cheese slicer, nor did I know that I had broken the cheese slicer. These facts were conveniently discounted and removed from the equation based on a false assumption, as if my nose was a tell. Facts can be disputed and ignored, especially when it comes to mental states, which are notoriously difficult to corroborate and correspondingly easy to lie about. Also, the absence of something, in my case the absence of intent and knowledge, is extremely difficult to prove. And looking back, I felt as if I was immersed in Kafka's The Trial and confronted with the impossibility of proving my innocence. That is why the burden of proof should always be on the prosecution, and why a simple, indisputable counterfactual can destroy the prosecution's case. It is the body of facts, taken as a whole, which must work together like a well-oiled machine to justify the hypothesis of what has happened, of what crime was committed. In the case of the broken cheese slicer, the hypothesis was that I accidentally, negligently, or intentionally broke the cheese slicer, then lied to cover up the deed. If I had been a better defense attorney, I would have pointed out that the guilty parties tend to hide or destroy the evidence of the criminal deed. The fact that I did not suggests I lacked knowledge and therefore intent. Unfortunately, we can't all be Perry Mason.